All right, today in Math 65 we're going to look at section 4.2, solving equations graphically. Okay, so today we'll take advantage of the graphing techniques we learned last week and create a new way of solving equations. This does not replace our algebraic method, but is simply a more visual way to look at the solutions. So does everybody recognize that this would be an equation that you would have solved in Math 60, right? Okay, so before we talk about graphing it, let's just talk about how we would solve it algebraically. What would you do if you wanted to solve this for x? 2x minus 6 equals negative 3x plus 4. What would you do if you were going to solve just for x? You could add 6 to both sides because you want to get all your constants on one side. Okay, so now we would have 2x equals negative 3x plus 10. What would you do next? Add the 3x to both sides. So we're just getting all of our variable terms onto one side. So we have 5x equals 10 now. What would we do next to solve for x? Divide by 5. And we get x equals 2, correct? Now, what would you always want to make sure that you do when you solve an equation? If you, check it! I love it that you said that. Okay, so if we check, let's see what happens when we check. What do we do to check to see if this is the correct solution here? Plug it in. 2 times 2 minus 6, is it equal to negative 3 times 2 plus 4? And we get 4 minus 6, that's negative 2. Negative 6 plus 4, also negative 2, so it worked out, okay? Now what we're saying is that's how we solved equations in Math 60. In Math 65, we're going to use the idea of the system of equations. So we're saying if I take one side of the equal sign and I write f of x equals, this is, by the way, the same thing as saying y equals this, okay? We take the second side of the equal sign and we set it equal to y as well. Y equals this, so we have two lines essentially. So this way that we just did it, the Math 60 way, is called solve it algebraically. I hope I spelled that right. It's probably on here someplace. When we solve it graphically, we're going to graph the two equations, the two functions, on the same plane to find out where they're equal. So if I go and graph this, how do I graph 2x minus 6? Yes, y-intercept, good, is negative 6. 2 over 1. 2 over 1. 2 over 1. Go up 2. Go over 1. Then, once we have enough points, we're going to connect the dots. So that's graphing that line. And then this one right here is, I'll just label it f of x, okay, because that's what we called it right over here, f of x. And then how do we graph g of x? G of x is, by the way, the same thing. It's just function notation. It means y. It means the same thing as y. Okay, how do I graph this equation here? Start where, go where? Start at 4 and go. Yes, down 3. 1, 2, 3, right 1. It's really throwing me off that these are a scale of 2, huh? Down 3, 1, 2, 3, right 1. Okay, and I really only need 2 points, so I'm going to just use those 3 points to draw my line. Now, notice where they meet. Where do they meet? Oh, where have you seen 2, negative 2 before? 2 is your x value. Oh, we got the same number, right? X equals 2 is the same thing, right? That's our solution. Where do you see negative 2? When you plug in 2, when you plug in x equals 2, you get y equals negative 2. That's the check. So your solution is 2. This is your check. And the reason why I say that, because normally you guys were like, remember in the last section I said the solution is the whole ordered pair. The difference is the solution to this equation is x equals 2. The negative 2 comes up when we check it. If I plug in x equals 2, right, I get negative 2 because that's the y value. There's only one variable. So the original equation here only has one variable. We introduced the second variable, y, in order to graph it on a coordinate plane. Okay? Try this technique for the next problem. So shall we, you can pause, if you're watching this, you can pause and then try it. But what would you do if you wanted to do this? Well, we can always first do it algebraically. If you solve it algebraically, that's going to tell you where your x value is, but you also want to graph, okay, y equals, y equals. So actually, let's have you guys try it, and I'll come around and then we can share out in just a moment.